For decades, we've been agonizing over the question of whether we're truly alone in the universe. Given the high possibility that life on Earth is not unique, it seems obvious that there should be aliens out there somewhere. But we've never seen or heard any evidence to support this. Is there some other, more sinister reason we haven't yet made first contact? This is Unveiled, and today we're answering the extraordinary question, are gamma ray bursts killing all the aliens?
Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one and ring the bell for more fascinating content.
Gamma ray bursts are explosions of unimaginably intense electromagnetic radiation caused by distant, extremely massive supernovae. Though it takes only seconds to produce a gamma ray burst, or GRB, they're as energetic as our sun, only with all that energy condensed into a single instant instead of spread across billions of years. We detect GRBs daily, but we haven't yet spotted one coming from inside the Milky Way. They're always from cosmic events in distant galaxies. Gamma rays reach Earth all the time, but they're absorbed by the ozone layer in our atmosphere, which prevents them from hurting us down here on the planet's surface. Gamma rays or not, outer space is highly radioactive, and life would almost certainly have never been able to form without Earth's protective atmosphere. Even with that protection, it's still dangerous to be exposed to sunlight for too long. The sun's ultraviolet radiation is ionizing, which means it can cause illnesses like cancer. But it still has the lowest frequency of all ionizing radiation. Gamma radiation, on the other hand, is the deadliest type of radiation, sitting right at the top of the electromagnetic spectrum with extremely high-frequency waves. Solar radiation and gamma radiation combine to make outer space immensely inhospitable, and radiation is a major worry for astronauts. It's why even the most seasoned space travelers haven't spent that long in space compared to how long they've spent on Earth. To make matters even worse, gamma radiation is also completely invisible. We couldn't see a GRB coming with our own eyes, and would need to depend on scientists to keep a lookout with high-tech instruments. This makes GRBs perhaps the deadliest cosmic events, since they can affect space much further away than even the biggest black holes. GRBs are one proposed solution to the famous Fermi paradox. The Fermi paradox is the problem that while life on other planets is statistically very likely to exist, we've not yet encountered aliens. At least, we have absolutely no concrete evidence that we've encountered aliens. So what happened to them? Why don't they want to communicate with us? And worse, what if something terrible has happened? Though GRBs are dangerous, the answer to the Fermi paradox doesn't have to be cataclysmic. It could simply be the case that aliens do exist on other worlds, but GRBs are too unpredictable and dangerous for them to venture too far beyond their planets. After all, space radiation is an obstacle that humans have yet to surmount as well. Even the best aluminum panels on a state-of-the-art spacecraft will eventually degrade, leaving both the passengers and the electronics in danger. And though NASA and other space agencies are working on anti-radiation drugs to help astronauts deal with radiation exposure and the damage it can cause, it's not likely that any pharmaceutical can cure someone if they're hit with a dose of radiation equivalent to all of the radiation the sun will output in its entire lifetime. If a spacecraft is hit with a gamma ray burst, it's going to be destroyed. And it will probably hit at such a wide area, potentially dozens or even hundreds of light years across, that there won't be any way to dodge either. There could be aliens out there, and maybe those aliens are even advanced enough to see us with powerful telescopes. But GRBs might be such a major hazard that it just isn't worth trying to make the journey to Earth, and vice versa. Even the most radiation-resistant organisms on Earth, the aquatic microorganisms called bedelloid rotifers, wouldn't stand a chance against a gamma ray from a neighboring star system. While this would be a sad solution to the Fermi paradox, at least it wouldn't mean that aliens are ignoring us on purpose, nor would it mean that there aren't any aliens out there at all. And we still might be able to communicate if we can find out where each other's planets are. In fact, perhaps aliens are already trying to communicate, but with so much white noise in space from distant radio sources, background radiation, gamma rays, and so on, we're just not able to hear their messages. Some space radiation is so loud that it's even been nicknamed space roar by NASA. Or perhaps their technology is level with ours and they just can't look far enough in enough detail to see that they're not alone. Then again, there is of course a much darker interpretation involving a similar answer to the Fermi paradox, the Great Filter. The Great Filter is an idea that says there must be something deeply wrong in the universe that prevents intelligent life from forming at the highly probable rates that the Drake equation would suggest. Something like, for example, gamma ray bursts. Earth could be extremely unusual not for its ability to host life, but for its ability to avoid cataclysmic gamma rays for such a long time. As a gamma ray burst in the Milky Way close enough to our location might be enough to destroy us. And with many billions of stars in the Milky Way, it's inevitable that one day, one of them will erupt in a supernova large enough to send a GRB in Earth's direction. The Great Filter implies that the universe does not want intelligent life, that intelligent life is something that's periodically wiped out, and that this is why we haven't seen the interstellar intergalactic megastructures predicted by Soviet astronomer Nikolai Kardashev. If Kardashev's scale of advanced civilization is right, it's assumed that by now we should see evidence like Dyson spheres, enormous metal shells constructed around stars to harness their power out there in the cosmos. The Great Filter says that something must be happening to stop Kardashev's scale from being right. Though, of course, it could also be that Dyson spheres are just unnecessarily large and expensive, and nobody wants to build one. So, what would actually happen if a GRB did hit Earth and we were subjected to this Great Filter ourselves? Well, since all GRBs are extremely powerful, if one happens close to us, it would completely annihilate Earth's atmosphere and burn us all to a crisp. Whoever survived the initial flare would quickly be finished off by solar radiation. That's why the surface of Mars is so radioactive after all, because its atmosphere is too thin to protect it from the sun. It's even been speculated by a small number of researchers that the Ordovician-Silurian extinction events 450 million years ago were caused by a GRB. A hypernova may have erupted only 6,000 light-years away from us. The only problem with this theory is that while there's no evidence against it, and many of the things that happened during the event are consistent with the theory, there's also no evidence for it either. You can't prove that something happened through the absence of contrary evidence. Mysterious as the extinction remains. But would a GRB really cause an extinction event? Some scientific evidence suggests that a large GRB has hit Earth, and a lot more recently than 450 million years ago, in the 8th century AD. But our evidence isn't contemporary reports of animals and people getting ill because of an unseen strange disease like radiation sickness. It's very real traces of radiation in ancient trees that stood 1,300 years ago, and ancient Antarctic ice that has been found to contain isotopes that could have been brought here by a gamma ray. If this is correct, it's good news for humanity. Statistically, a GRB only happens every 10,000 to 1 million years per galaxy, or thereabouts. While the universe has no obligation to abide by our statistics, this does mean that the Milky Way might have had a large GRB in the extremely recent past, and we barely even noticed. However, the cause of this GRB would still remain a mystery. There are no visible remnants of a local supernova. A leading theory is that it could have been caused by a collision of black holes or neutron stars. Aliens heading into outer space are likely more at risk from other, more predictable forms of radiation long before they get hit by deadly gamma rays. And that's why aliens probably aren't getting killed by gamma ray bursts.
What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.